All right. Today is 12th Tuesday, so we'll cover the second part of ocean renewable. And homework 2 will be out late night or tomorrow. Speak please, right? And today lecture will be done both part by myself. So I hope we can do the discussion in between of my two lectures. It's more effective, I guess. So, any other questions, schedule or other items? No? And I want to. Oh, that's not a question.
So, regarding the midterm exam, that's the week after the midterm. So the midterm exam will be the week after the midterm.
Right. During the class hour.
I might not be able to time the 21st.
21st will not be, will be absent.
No, not physically.
June, is it okay? Okay. And it's schedule conflict. No. We can go on to schedule. And did I send you the how to exam? Right? No. Motion renewable. So third part, and I will cover the current part. Also thermal energy, so ocean thermal energy or ocean current energy. This part. So there are variations on numbers, so you should be careful about this. I got from Google search, but different people provide different numbers. Say something like power density or energy density I mentioned to you. So there are big difference between traditional energy source like gas and coal to solar, wind, and renewable. The problem is very low level of power density. For economy can be a problem. And also between solar and wind, this chart shows you that solar is better than wind in terms of power density or energy density. But also here, solar and wind is similar, right? And then planting tidal, also two there. Tidal is lower, and raining water, and also solar power. Solar power with the concentration is big number. But the other chart shows you different. Solar radiation is lower than wind and tidal water. So this chart shows that wind is more better than other patterns. And the other one also, you can find the chart from this website. And coal and gas and nuclear and biomass, geothermal. This is cost rather than energy density. So cost is including the production cost too, right? The device and also operational cost and investment cost. Here, wind is cheaper here, right? Very cheap. Comparable to gas and coal, right? So should be, and then onshore and offshore. Offshore is much expensive than onshore, but it's also debatable because the size should be also included. Typically, onshore wind turbine is smaller, much smaller than offshore one. So, economy of scale also solar cells are developing very fast. The technology, so that the cost is lowering down every year. We should be careful. Current energy, ocean current. There are, because it is coming from wind and also the rotation of the Earth. And also there are another deep ocean current called driven by density and temperature gradient. And this one called us as a global conveyor belt. They transport some biomasses or bio items to different places. This one also too, current, because this is current. Crucial, as I explained before, is near Philippines, Taiwan, and Japan. That gives you higher ocean temperature near the southern part of Japan, because of the warm water is coming every day. And this one is a deep ocean. So shallow water, shallow part is driven by wind, and deep water is driven by deep ocean current. Okay, and this is a conveyor belt, ocean conveyor belt. Looks different from previous ones. It is very slow, but it is warm surface current and cold deep current, and coming up and down again. It is interesting. I guess there's a video for this. Let's see this.
저는 그런 생각이 드는 것 같아요. 가서 누군가는 도와야 하지 않을까. 저는 의사고 환자를 볼 수 있는 지식과 기술을 가지고 있고 그 현장을 보고 있으면 아, 내가 가서 도와주고 싶다. 내가 가고 싶다. 안녕하세요. 저는 올해 2월에서 8월까지 6개월
In 1992, a cargo ship carrying bath toys got caught in a storm. Shipping containers washed overboard, and the waves swept 28,000 rubber ducks and other toys into the North Pacific. But they didn't stick together. Quite the opposite. The ducks have since washed up all over the world. We used their paths to chart a better understanding of ocean currents. Ocean currents are driven by a range of sources: the wind, tides, changes in water density, and the rotation of the Earth. The topography of the ocean floor and the shoreline modifies those motions, causing currents to speed up, slow down, or change direction. Ocean currents fall into two main categories: surface currents and deep ocean currents. Surface currents control the motion of the top 10% of the ocean's water, while deep ocean currents mobilize the other 90%. Though they have different causes, surface and deep ocean currents influence each other in an intricate dance that keeps the entire ocean moving. Near the shore, surface currents are driven by both the wind and tides, which draw water back and forth as the water level falls and rises. Meanwhile, in the open ocean, wind is the major force behind surface currents. As wind blows over the ocean, it drags the top layers of water along with it. That moving water pulls on the layers underneath, and those pull on the ones beneath them. In fact, water as deep as 400 meters is still affected by the wind at the ocean's surface. If you zoom out to look at the patterns of surface currents all over the Earth, you'll see that they form big loops called gyres, which travel clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. That's because of the way the Earth's rotation affects the wind patterns that give rise to these currents. If the Earth didn't rotate, air and water would simply move back and forth between low pressure at the equator and high pressure at the poles. But as the Earth spins, air moving from the equator to the North Pole is deflected eastward. Air moving back down is deflected westward. A mirror image happens in the southern hemisphere, so that the major streams of wind form loop-like patterns around the ocean basins. This is called the Coriolis effect. The winds push the ocean beneath them into the same rotating gyres. And because water holds onto heat more effectively than air, these currents help redistribute warmth around the globe. Unlike surface currents, deep ocean currents are driven primarily by changes in the density of seawater. As water moves towards the North Pole, it gets colder. It also has a higher concentration of salt, because the ice crystals that form trap water while leaving salt behind. This cold, salty water is more dense, so it sinks, and warmer surface water takes its place, setting up a vertical current called thermohaline circulation. Thermohaline circulation of deep water and wind-driven surface currents combine to form a winding loop called the global conveyor belt. As water moves from the depths of the ocean to the surface, it carries nutrients that nourish the microorganisms which form the base of many ocean food chains. The global conveyor belt is the longest current in the world, snaking all around the globe, but it only moves a few centimeters per second. It could take a drop of water 1,000 years to make the full trip. However, rising sea temperatures are causing the conveyor belt to seemingly slow down. Models show this causing havoc with weather systems on both sides of the Atlantic, and no one knows what would happen if it continues to slow, if it stopped altogether. The only way we'll be able to forecast correctly and prepare accordingly will be to continue to study currents and the powerful forces that shape them. What about the creatures that adapted to survive in these swirling seas?
Interesting, right? And complicated. Alright, so then we move on to current knowledge. So ocean current energy potential slower than wind. Right? Ocean current is slower, but density is 800 times higher for water than air. So that 12 mile per hour current speed is equal to 112 mile per hour wind. So the energy level potential is different. Gulf Stream, or 1,000th of the energy of the Gulf Stream can satisfy the Florida energy need. The scale is big. And once again, we try to see the Grosso current again from Wikipedia. So the current is near South or East Asia, Far East Asia, Japan and China, Korea. This one is the main current from south. So some portion is going. That's why the warm water is located. I guess you remember this picture or video coming from NASA. Shows you the picture of brochure current is moving. And then how can we capture that current energy? If there is a stream of water is flowing, there can be a submerged water turbine, very similar to the wind turbine. But the scale and speed and density is much different because it's not air, it is water. But shape is very similar. Similar to wind turbine, but the post should be fastened to the ocean floor. And there are two types, similarly, the vertical type and horizontal type. That is very similar. And in Nagasaki, Kyushu is, let's see, Kyushu is something like, Kyushu island is this one. Japan is made of four big islands. One, this is the main island, Honshu, Hokkaido. This is Kyushu island. And we are seeing this Kyushu island more closely. And probably this one is a corner of Kyushu island. And then we are talking about this smaller island here. They put this turbine, diameter 60 meters, much smaller than wind turbine. Wind turbine is 150 something. But megawatt, 2 megawatt turbine. For the wind, it should be about 100 diameter. But it is 16 is also. And RTM 2. And so in the United States, there are 3 major currents in the United States that can be captured. So I missed one thing to explain this. This is, you may see from a previous chart that the place is about here, the Kyushu island. So they are trying to capture the energy coming from a Kuroshio front. And you may expect that near Taiwan and also Philippines, there can be another good places for such a project. And near United States, there are 3 Gulf Stream, Gulf of Mexico, and Florida Strait, and also California. This is another video. Let's see.
We hear about strange things from distant places being washed up on our shores all the time, but how do they get there? Ocean currents are the movements of surface water in the oceans. Their direction is influenced by many factors, including the rotation of the Earth, the size and shapes of the continents, the prevailing winds, and even water density. Ocean currents caused by prevailing winds are called drift currents. In the northern hemisphere, the circulation of the oceans is clockwise, and in the southern hemisphere, the currents are anti-clockwise. Currents originating from the polar regions carry cold water. There's the California current, the Peru or Humboldt current, the Labrador, Canaries, Benguela, the Antarctic circumpolar currents, and the Oyashio. Currents originating from the equatorial regions carry warm water. There's the Gulf Stream and North Atlantic Drift, the Brazil Current, the North and South Equatorial Currents, and the Kuroshio. So perhaps it's not so surprising that many of the items that are washed ashore originate from far-off places, thousands of miles away.
So that you may
Circumpolar currents and the Oyashio Drift, the Brazil Current.
the warm current is coming toward the northern Europe here. That's why even though the latitude is high position comparing to Korea or Japan, So temperature is more higher than expected because of this one part. All right. Summer, not current. What is summer? Temperature difference. Right? There's a geosummer and also ocean summer. So there's a video. Geosummer is in land-based, and ocean summer is from ocean-based. Let's see the video too.
What's it like to learn science on Brilliant? Brilliant gets you hands-on to help you learn by doing. From thermodynamics
Okay. Move on to slide on. So how to use that geosummer? Already we explained. How to use source? So deep the land, there can be a hot spring over there. Dry rocks, hot dry rocks over here. Volcano something. So that there can be one injection well to produce hot spring pressurized water temperature coming. Then you can utilize to use steam turbines, and also cold water should be injected. All right. Questions? No. Then we can go on to discussion session. 뭔가 잘못됐어요. 이쪽 갖고 와서 일단 녹화 잠깐만 세팅. 다시 세팅하고. 이제 사운드 다시 들리죠?